All right, so in this case, we're looking at problems with circular arrangements. They're a little bit tricky. They're different than our regular methods. Our question here says, 6 members of the yearbook staff sit around the circular table in their office. How many different seating arrangements are there for this group of people? So this differs from our previous questions. In our previous questions where we had everything in a straight line, the problem was quite simple in that we took, in the first position, there could potentially be one of 6 people that would be there. We'd then be left with 5 possibilities for the second spot, followed by 4, followed by 3, followed by 2, followed by 1, which gave us an answer of 6 factorial. It's a little bit different here because of the fact that we're in a circular arrangement. And the reason for that is that if I consider myself as this is being one of my spots, I'm going to show the fact that we can basically rotate around the table here. So that position number 1 could potentially be in position number 2, 3, well, whoops, go back here. Let's say that's position number 1, 2, 3, 4, 5, or 6. If we have our 6 people seated around that table, they can be rotating around and they're really sitting in the same arrangement. So the trick to this means that we have to lock one person in place. So our problem, in this case, we'll do our proper solution. We're given 6 people in a circular arrangement. We are required to find number of different seating arrangements. And so our solution is to lock one person in place. And the idea behind that is that we're now in this possibility of kind of rotating around the table. It might take you a little bit to think about that, get your head wrapped around it. But for this particular case, we simply need to recognize for our circular problems, we're going to lock one person in place. So if we lock one person in place, this is our first person, we're then left with, in the second spot, in our second spot, we're locking one person there. We're now left with 5 possibilities in the second spot, 4 possibilities in the third, 3 possibilities in the fourth, 2 possibilities for the 5th spot, and then 1 possibility in our 6th location. So that is the same as actually saying 5 factorial, and that we know is 120. We can say, therefore, there are 120 possible arrangements around the table. Example 2, 5 men and 5 women sit around a circular table. How many different seating arrangements are there if they must sit in an alternating fashion? So again, we are given 5 men, 5 women. We're given a circular table. It's important that we recognize this circular table. We have no beginning or end in the circle. What are we required to find? Number of arrangements if alternate seating. So no man will sit beside a man, no woman will sit by a woman. It's always man, woman, man, woman. So in this case, our solution, again, we've got 10 spots. We've got a total of 5 women, 5 men. So we've got 10 locations around the table, 3, 4, 5, 6, 7, 8, 9, 10. We're going to lock one person. It doesn't matter if it's a man or a woman. Let's lock our first woman in place. That leaves in the second location, so this is our first location. In our second location, we have 5 men to choose from. We now have our third location. There are only going to be 4 women left, followed by 4 men left, followed by 3 women, followed by 3 men, followed by 2 women, by 2 men, 1 woman, 1 man. So those are the possibilities when we're looking at an alternate seating arrangement. When we use this, put this into our calculator, we get a total of 2,880 possible arrangements. And we finish with our statement. Therefore, there are 2,880 possible seating arrangements. You can see your homework listed down there. If you've got questions, be sure to ask.